Hello, and thank you for studying CCNA with Vombar. Today, we're going to extend our knowledge of WAN technologies by going into the details of a layer 2 encapsulation protocol called frame relay. However, if you have troubles remembering some details about WAN technologies and some other layer 2 encapsulation protocols such as PPP or HDLC, I suggest you to review the ICND1 video called Introduction to WAN Technologies first. So now let's go into the details and let's familiarize ourselves with the frame relay details. Well, firstly, we will talk over what exactly frame relay was and what is used for. Then we'll discuss things like local management interface or LMI and inverse ARP. After that, we'll define different types of frame relay sub-interfaces and how do we use them in the big picture. And then in the end, we'll configure frame relay. In the ICND1 video introduction to WAN technologies, we said that frame relay is said to be packet switching technology. And as such, frame relay requires virtual circuits to be established prior to sending the data. Well, we have two types of virtual circuits, permanent virtual circuits and switch virtual circuits. Permanent virtual circuits are permanently established and they're there for you 24/7, so you can send data all the time. Whereas switched virtual circuits have to be established each time the data is about to be sent. For the purpose of this course, we're going to use only PVCs or permanent virtual circuits. So in our example here, we'll have two permanent virtual circuits or PVCs. One from New York to Los Angeles and another one from New York to Washington, D.C. Basically, the role, again, of those virtual circuits is to define the interconnection between the devices, meaning how are they connected between each other and to whom they will send the data. So it is said that, for example, Los Angeles cannot send data directly to Washington, D.C. Even though they're connected, they have to send the data through the permanent virtual circuits or the PVCs. Every virtual circuit is identified with a number called DLC or Data Link Connection Identifier. Each side of the virtual circuit identifies that virtual circuit with its own DLC. They're provided to you by the internet service provider and they can be either the same or different. From your point of view, it doesn't really matter since you're paying for the communication to a remote site and it is the ISP's job to take you there. And he's the one who gives you those DLCs and tells you, okay, if you use this DLC, it will take you to your correct destination. So, for example, the New York router identifies the virtual circuit to LA with a DLC number 100, whereas the LA identifies that same virtual circuit with a DLC number 200. In other words, the Los Angeles router, it says that if he wants to go to the New York router, he needs to use DLC number 200. On the other side, on the virtual circuit between New York and Washington, D.C., they both identify themselves with the DLC number 300. It is said that the routers use those numbers as layer 2 addresses since there is no such thing as MAC addresses in the WAN world. So those are the addresses that all routers will use, and they'll substitute that for the MAC addresses. The cloud is called the service provider's cloud, and inside that cloud there's an interconnected network of frame relay switches. They act just like any regular switch, but instead of MAC addresses, they do their switching decisions based on DLC numbers. And again, it must be noted that even though all the routers are physically connected, just like the LA and the DC routers are, they cannot communicate directly to each other unless they have an established virtual circuit between them. So if LA wants to talk to DC, well, the LA needs to use DLC number 200 to go to the New York router, and then the New York router has to use a DLC number 300 to send the packets to the DC router. Physically, the packet or the frame takes this path, and it is predefined, as we said, by the virtual circuits. It is said that this type of topology is called NMBA or non-broadcast multi-access. This means that the network does not have any intrinsic broadcast or multicast capabilities, but still can provide a full mesh-like communication by the use of virtual circuits. Well, configuring basic frame relay is actually very easy. All you have to do is within the interface that you want to configure frame relay, you have to type the command encapsulation frame-relay. And that command enables frame relay as an encapsulation. So let's see it in an example. Well, right now in this example, we're going to configure encapsulation frame relay on the serial 0/0/0 on the New York route. So to do this, well, in global configuration mode first, we would have to type interface serial 0/0/0 to go into that interface. And this indicates us that now we're going to be in config-if mode. And then after typing the command, encapsulation frame relay. By typing the command, the LMI on our route will go and communicate with the frame relay switch, which will then bring us the statuses of our DLCs, which we have DLC 300 and the status is active. So that means our PVC is good to go. After that, inverse ARP will go and send a request to the LA router, which will then send us a reply allowing us to create what we know as the frame relay map statement, which maps the remote IP address to our local DLC, meaning again that if I ever want to go to this IP, I would have to use DLC number 300. And this frame relay map statement enables us to send and exchange packets between the New York and the LA route. Sometimes we don't want to use inverse ARP to map our local DLC number to the remote IP address. Some of the reasons would be that, first of all, the frame relay is said to be a non-broadcast multi-access network, which means that it does not allow broadcast packets to traverse through the PVC. Well, sometimes we want to traverse or we want to send broadcast and multicast traffic through the PVC because, let's say, every single routing protocol uses multicast and broadcast. Also, another reason why would you want to use inverse ARP to map your local desk to the remote IP address would be that sometimes the encapsulations on the LMI on the two ends might be different, and inverse ARP cannot perform the mapping statements correctly. Well, this is where luckily the command frame relay map IP remote IP address local DLC and the keyword broadcast comes into play. This command allows us to create a static mapping entry between our local DLC number and the remote IP address, and with the keyword broadcast it will allow us to control whether or not we want broadcast and multicast traffic to pass over the PVC. Well, let's see how we can configure static entry on the 0/0/0 of the New York router. All we have to do is first go into the interface with the command interface 0/0/0 in global configuration mode, and then type frame relay map IP remote IP address, then local DLC, which is 300, and then the keyword broadcast. Now this command will allow broadcast, multicast traffic, any kind of traffic to traverse over the PVC. Also, this entry is already static, so it's not dynamic, so we don't have to wait for inverse ARP to go and create the statements for us, so we can just simply send the actual packets around. And that's what this actually command will do.